Our third video in this series, we are going to look at Goal 21, where we will understand and use the inverse tangent function. So again, let's start by looking at tangent to determine if it is a one-to-one function. And we see that it also is not a one-to-one function. So just like sine and cosine, we are going to have to restrict its domain. So why don't you take a moment, analyze the function, and see if you can determine what the restricted domain might be. All right, so let me drag this viewing window around. You can see that if we lay it on -3 pi over 2 and positive pi over 2, tangent is 1-to-1. If we slide it to -pi to 0, it is no longer 1-to-1. Actually, yeah, it would not be 1-to-1 because if we looked at these 2 points here and there, it would intersect. But if we continue to slide, we're at -pi over 2 to pi over 2, it's 1-to-1, and we can continue that fashion. So the restricted domain for tangent of x is -pi over 2 to pi over 2. So the restricted domain for y equals tan of x is the same as sine, except that, remember that because these are vertical asymptotes at -pi over 2 and pi over 2, then our restricted domain will have parentheses around them because we can't equal where a function is undefined. And now our range, however, is not like sine and cosine. Because the function continues to positive and negative infinity, our range is negative to positive infinity. Okay, so what happens with the inverse trig function? You know the drill here. The domain becomes the range of inverse tangent, and the range becomes the domain of inverse tangent also. So let's put that on our coordinate plane to graph the inverse function. So our range is now -pi over 2 to positive pi over 2. Our domain is -infinity to positive infinity. Let's take a few ordered pairs. We know that we have an ordered pair of -pi over 4, -1. So if we take the function value -pi over 4, -1, and switch those, then we would go left 1, down pi over 4. 0, 0 remain put. And we also know that we have an ordered pair of 1, or pi over 4, 1. So we could go over 1, up pi over 4. I know that I have vertical asymptotes at -pi over 2 and positive pi over 2. So for the inverse, those would become horizontal asymptotes. And now we can sketch our function for the inverse. So you can see that the domain of inverse tangent is -infinity to positive infinity, but the range holds between -pi over 2 and positive pi over 2. So we'll put those on our unit circle. And just like sine, or inverse sine, inverse tangent also is maintained in quadrants 1 and 4. And I'll remind you of the values of tangent. At pi over 2, tangent's undefined. At pi over 3, it's √3. Pi over 4 is 1. Tangent of pi over 6 is √3 over 3. Tangent of 0 is 0. And then all the values here would just have negative signs. Okay, so let's practice the examples we have. So remember that arctan means we are solving for an angle. So theta equals inverse tangent of opposite over adjacent. So at what angle is tangent equal to the square root of 3? And that would be pi over 3. At what angle does tangent equal 0? If we refer to our unit circle, we see that that is 0. The third example, at what angle does tangent equal negative root 3? So we have to go to quadrant 4 because that value is negative. And so we know that is at negative pi over 3. And lastly, inverse tan of 1. So we'll go to quadrant 1, and that is pi over 4. So it's important that you finish up these 3 series of videos by making sure that you know the domain and range of the 3 inverse functions. So I want to review that quickly. Recall that in order to come up with the range for inverse sine, we take the restricted domain of the given function. Remember, the restricted domain for sine was negative pi over 2 to pi over 2. Therefore, the range of inverse sine is negative pi over 2 to pi over 2. Cosines, inverse cosine's range is 0 to pi. And the range for inverse tangent is negative pi over 2 to pi over 2. Remember that the range for sine and cosine is negative 1 to 1, so the domain for inverse sine and cosine is negative 1 to 1. And then tangent has a range of all reals, or negative infinity to positive infinity. Therefore, the domain of inverse tangent is negative infinity to positive infinity. And recall that with inverse functions, your range is represented by theta, and your domain is represented by the function values.